Hi everyone, welcome to Navigating Cloud and Platform. This is Mike, the UK Platform Capability Lead. He's going to take you through Navigating Cloud and Platform, and please ask any questions into the Q&A box or into the chat, and we'll go through them at the end. But for now, I'll hand over to you, Mike.
Thank you very much, Chloe. So good afternoon, everyone. Thank you very much for your time. My name is Michael Fordham. I'm the Platform Capability, UK Platform Capability Lead for BJSS. We have spent in the region of around 200,000 hours this calendar year on cloud and platform projects in BJSS, and what that has afforded us is a really interesting insight into how organisations like to adopt and use the cloud, what we do from a cloud engineering perspective. And that covers a raft of projects from large digital transformation, enterprise adoption, right through to very specific sort of cloud native serverless projects. And it's also started to give us an insight into sort of brownfield cloud, so organisations that have made the first step into the cloud. Maybe haven't realised the value that they first expected, and it's given us an opportunity to go in and help them sort of realise that value, either from a cost perspective or an engineering perspective or a security perspective. So what I'd like to do today in this half-hour session is just talk about some of those themes that we see across cloud adoption and cloud engineering. And then I'd like to leave a little bit of time at the end of the session for anyone to ask questions and myself answer them. And I'd like to be challenged on anything that I say. One of the best parts of these sessions is that they're interactive, and I get to learn as much as I hopefully get to share some of our experiences. So please don't be shy and ask any questions and challenge me around what I say. So what will we talk about today? So what is successful cloud adoption? We'll sort of talk about that at an architectural or a conceptual level, but there will be some very common themes in there. We'll talk about what this really means for cloud engineering and what the traits of successful delivery are. And then we'll attempt to talk a little bit about the future and what the last year has told us around what we need to consider in the future. So they're effectively my hot takes, but they're my hot takes based on what we do as an organisation and what we've seen in the field. Okay, so at a high level, what do we consider successful cloud adoption? So absolutely talk about scale, take advantage of the inherent sort of scalability of the cloud, resiliency, cost optimization. That's not just selecting sort of right sizing your instances or right sizing the services you use, but also using them on demand. Make sure it's absolutely loosely coupled. Anything you do in the cloud, make sure that's loosely coupled. I'll be talking a bit more about that later. And of course, security. And we can talk about these as sort of architectural or design principles. Of course, you bring them all together and you will make something beautiful architecturally and it just works, right? Or is it a bit more harder than that? I think it's a bit harder, but it is, of course, possible. So at a cloud engineering level, what do we make of these 5 things and how do we achieve them? So I like to refer to like the pillars of cloud engineering. There's 3 of them. They're not mutually exclusive. They can't stand together alone. They stand together. They have to sort of rise as one. Infrastructure as code. So absolutely massively important to anything we do in the cloud. It helps us with security. It helps us with repeatability. It helps us with quality. And it helps us scale as well. Really, really important. CI/CD. So these are not exclusive terms to platform, of course. They will be goals of anyone that operates in the cloud and develops applications in there. But they also underpin how you deliver cloud platforms as well. And automation. Automate all of the things. Don't do anything more than once if possible. Look for opportunities to streamline and create a really, really efficient process and adoption of any cloud services and layering your application on top of them. Again, they're very conceptual, right? They're fairly well understood. They're the things that everyone starts off every cloud project with the intention of doing. We need to make these a bit more real. We need to bring this down one more layer into the real cloud engineering and talk about how we actually attempt to achieve these in projects. So I'm going to talk about cloud engineering discipline now, and they are really, really important to everything you do. When you start to work with cloud platforms and you realize that you have this myriad of tooling available at your fingertips, it's really exciting. And there's the possibility that you just start to get a bit carried away and you just start to do what technology can do rather than what you should be doing with it. So there's three questions I always ask myself on any project I'm on, and what our BJS engineers sort of primarily look at whenever they're on a project, and they're as follows. Whenever you're attempting to do something, what is the problem you're actually trying to solve? What is the objective you're trying to meet, and how can the technology help you, rather than I want to use this piece of technology and I want it to work this way. Always map it back to what you're trying to achieve. And then when you've decided how you're going to do it at an engineering level or an architectural or design, make sure it's clearly understood why you've done that. If it's not actually clear why you've made that decision, is that the right decision to be made? Or do you have to make it clear to someone because you've looked into things and this is the only way to make it work? And then also consider what happens if it breaks. If it breaks, does the rest of the service go down? Does it fail gracefully? Can I auto-remediate the fixing of the problem? Or does all hell break loose and everything goes down and we're in a lot of trouble? So always think about these three things when you're working in the cloud. Treat them as like your North Star, treat them as like your anchor to any decision making that you do at an engineering or architectural level, and use them to challenge what you have been asked to do as well. If you get given a prescribed solution, actually ask what these three questions around that prescribed solution. And it's all about trying to strip complexity away from what you're doing and do things in the simplest and best way for you and your client. So I'm going to talk a little bit now about being loosely coupled. And I consider this to be one of the most important things you do in the cloud. And the way I try to do this is I try to think of services in the cloud as microservices. And if you take a common sort of microservice architecture, the idea is that a microservice works in its own right. It is a part of a long process or an aggregated solution. And if you want to make one change to the solution, you only change the microservice to which that relates. And you have to have a bit of management and discipline around how many microservices you have, of course, but the idea is that you are able to change your system without treating it as a monolithic application or as a service. And I try to think of all the cloud native services in that same way. I try not to tightly couple them. I try not to make solutions too big in aggregate that change affects lots of things. I just try to adopt cloud services and make changes to cloud services that I've configured on a per service basis where possible. And change is your friend in the cloud. It is something you have to be really comfortable with. You will have to pivot multiple times whenever you work in the cloud, because during the course of your project or your program, you will always have changes to cloud services that you will need to take into consideration. You will always also have to take into effect that a change to another part of the cloud might impact your service in a separate part. And so you have to be really flexible and adopt change very easily. It's your friend. It's not something to be afraid of. It's something that you need to embrace, and you need to wrap around your engineering and make sure that you can adopt it very easily. And also think about how you turn off systems. A lot of the times when we look at application services and platform services in the cloud, we always ask ourselves two questions. We say, how easy is it to deploy? And how easy is it to operate? The question that rarely gets asked is, how do we turn this off? And if you create something that's very hard to turn off, in 5 years, 6 years, 7 years, or however long your cycle is for this application service or this platform service to be running, you'll be bemoaning this in the same way that we do on-prem services and on-prem solutions right now that have created monolithic applications where we don't actually know how to migrate from existing state to current state. Because what you don't want to be is in this situation where there's an off button, but actually there's two of them and you don't really know how to turn it off, and it could break if you do that, and you don't really know how to migrate from one to the other. So if you can actually think about how you turn off systems in your cloud designs and your cloud engineering, you can make a more informed decision as to what that needs to look like. I talked a bit there about why I think change is good and why you need to embrace it in cloud engineering rather than be fearful of it. So, you know, it's well understood. We don't really like change as humans. We like to know what we're going to do. We like the routine. We like the certainty of what we do. And it's no different in IT, but actually, especially in the cloud, we really need to embrace change, because if you don't, you will fail. Services change too quickly. Decisions are made further down the line when you start off on one path that impact what you wanted to do previously. And you need to understand that change is something you need to embrace, and change is something that you need to incorporate into your design and your engineering, because it will happen. I have not yet worked on a project where we started off down one path and a new service came out, or a cloud provider changed how a service worked, and we needed to go back and either remediate or enhance something that we'd already done. And it's very hard to do that if your processes and your engineering doesn't embrace change and allow that to happen gracefully. So as a consequence, we loosely couple, right? We loosely couple in order to give us a better way to deal with change. And that goes back to what I just talked about around treating cloud services as microservices, understanding what loose coupling means, understanding that you configure something, but you don't want to tightly couple it to something else, because if that thing changes, then it also impacts anything else that you've tightly coupled to it. Because what you don't want to be is like this. You don't want to be yelling at your cloud provider for providing something new, something different that absolutely breaks what you've got. And for those of you that work in AWS, we are on the verge of AWS reInvent. I can guarantee they're going to announce some new fantastic services or enhancements to existing services that will break what you've got, that you need to consider in what you've got, or give you a better way to do something with what you've got. And you need to find a way to incorporate that into your engineering and your designs. And you can't do that unless you're loosely coupled. You can't do that unless you've got your engineering discipline that allows that to happen. If you've gone into the cloud and created a monolithic service, a monolithic application, these are breaking changes rather than changes that you will embrace and make things easier and better for you. Because here's a flavor. This is what I've taken from the AWS console. Of course, other cloud providers are available. But look, there's over 100 services here, and very rarely do you use any one of them in isolation. You will use up to dozens of them for your needs, and you need to consider how changes to any of them impact you. And I can't stress this. I can't stress this enough. And it's hard enough to keep on top of it all, absolutely. But when change happens, you need to be able to embrace it, and that goes right down to how you code, as much as it does around your architectural principles and how you approach solutions in the cloud. Something else that crops up quite a lot is how cloud native should I be? And cloud native is, again, quite an emotive term, and it has different interpretations, really. So for the purpose of this discussion, I'm going to talk about cloud native as actually using cloud services that the cloud provider provides for you without the need to deploy your own infrastructure. So stay away from instances or servers, and actually use the services that AWS, Azure, GCP and other cloud providers give you out of the box that allow you to create platform or application services, or even write applications. In a way, the best way to think of it is that cloud native services take away the undifferentiated heavy lifting that you would commonly associate with on-prem infrastructure, and allow you just to consume that as a service that's available to you in the cloud. And actually, it is good to be cloud native for the reasons I've just said. They take away all that heavy lifting. They take away the feeding and watering of servers. They take away the challenges of scalability in many instances. Essentially, it's a plug and play service, and it allows you to do things really quickly. And all of this is really good stuff. But it cannot be an unconditional principle to apply. You can't just say you're going to be cloud native, and if that service exists, you just blindly adopt it. You've got to clearly understand your use case for it. You've got to understand the limits of that cloud native service, because quite often it is not as functionally rich as services that you might be able to deploy yourself on servers or instances. And then you've got to know what your requirement is and challenge it accordingly. And this can go both ways. So first of all, you have to know what you need to achieve and map that to the cloud native service and determine whether or not that cloud native service can functionally meet your requirement. But also you'd use it the other way. If your requirement does not map to the cloud native service, does your requirement need challenging? Are you trying to do something that actually you needn't do and there's a better way to do it? And unfortunately, there's no clever algorithm for this. This comes with experience. It's fair to say that not all cloud services are equal. You will find more maturity in some AWS services, as you will Azure, as you will GCP. And you will also, within those ecosystems, realize that not all services are equal, that some are second-class services in AWS that exist and aren't particularly well-rounded or particularly mature, and it'll be the same in Azure and GCP. So it takes some experience to look at this. It takes quite a methodical approach. Absolutely adopt cloud native as a principle, but don't blindly adopt it. Apply some rational thinking to it. Understand the consequences of adopting it, because once you adopt cloud native services and use them to host everything you want to do, you're sort of bound to the functionality that provides. And the one thing we do know from the cloud is that when you start to try and bend and break services, you introduce complexity, you create a lot of operational overhead, and it might not work. And it's very hard to embrace change when that works. So just apply some rational thinking to adoption of cloud services, but absolutely use it as a first principle with anything you do in the cloud. So feedback is very important in the cloud. And by feedback, I mean the myriad of metrics that can be provided to you by your cloud provider around how your configurations and your cloud platform services and your applications are behaving. Get metrics on everything you do. It's really, really important, because it informs you what you need to change and how. It can strip subjectivity out of everything you do at a design and engineering level. It stops the loudest voice in the room, or should stop the loudest voice in the room telling you what needs to be done, because you can refer to some evidence-based data to make evidence-based decision-making to say, look, the system's telling us this is what we need to do as a consequence. Or we've got a pinch point in performance here, we need to address it by looking at this one component and try understanding how that scales more, or even swapping it out for something else. One of the things we see quite commonly is that organizations are really, really happy with how how something works in the cloud, but they don't really know how to improve it and how to adopt that sort of continuous improvement approach to cloud adoption. And actually, it's the metrics that allow you to do that. And they are as rich as you want to make them. All the cloud providers will provide it at a service level. If you are deploying applications in the cloud, make sure you get as functionally rich logs and feedback from those applications. You marry the two together, you bind it with some automation and auto remediation, and you have a really powerful tool for continuous improvement and successful cloud adoption. Don't be like the gentleman in this picture who says he's open to feedback, but then ignores it. That feedback there exists to help you and allow you to make informed decisions. Take advantage of it. The cloud's brilliant for it. Don't forget the delivery methodology. We've talked about the need to embrace change. When I say agile, I won't get into the emotive discussion of what agile delivery means, but as cloud engineers, we need to find the best agile delivery for our needs, for the processes we need to follow. But I can say, because of the need to pivot, because of the need to embrace change, agile delivery does underpin successful cloud engineering, and you always need to be cognizant of that. And definitely don't forget the organizational impact of successful cloud adoption. I've put a rather vague term here in my lazy Google search, but there's over 44 million hits there. Don't worry about phrases like cloud center of excellence or cloud operations, DevOps, DevSecOps, DevFinOps, DevSecFinOps. These are all terms that basically talk about a different way to do things in the cloud and the need for an organization to adapt to that. I would encourage that anyone who's making first steps into the cloud not only looks at the cloud as a technical platform to achieve things very quickly and with a great deal of quality, but also uses how the cloud works as a way to challenge internal process of getting things done. As I say, the feedback and the metrics you get from cloud operating in the cloud are so rich, and the ability to marry that with automation can challenge how you do things organizationally. And so a lot of successful cloud adoption is about setting yourself up as an organization for the cloud as much as it is doing things in the cloud. And I would always sort of talk about that in the first instance with any client that's talking about going to the cloud and what they need to consider. Okay, so what I've done there is I've talked a little bit about sort of the principles of successful cloud adoption. I've talked about some of the things at cloud engineering level that I believe are really, really important and are the things that we see delivering for our clients and with successful deliveries. What I'm going to do now is talk a little bit about the future. Of course, if I knew exactly what the future looked like, I definitely wouldn't be sitting here in front of you. But we can talk about these things as the areas that we're increasingly talking with our clients about, that we're increasingly seeing delivering great projects for our clients, and the things we're starting to really look at internally about the future of cloud engineering. Okay, so this won't be new to anyone. Explosion of data and how cloud engineering underpins it. This covers both machine learning and data lake smarts warehouses. I have a tendency to use the data lake smarts and warehouses interchangeably. Those in BJSS tell me off for doing that because they mean very different things. But what I'm saying here is that you need to consider how you can manage data in the cloud, how you can process data in the cloud, and how you can get informed information and views from that data in the cloud. And shifting data around in the cloud can be something you really need to think about. Quite often we just think of databases, and it's not really about that anymore. It's more about how quickly can data warehouses, data marts, data lakes exist, and how quickly can they be integrated into any application or machine learning that you want to apply to them. And it sort of changes the way you think about data and think about cloud platforms moving forward. Edge computing and what that means. So by this I mean increasingly the distribution of compute out into the field as computer chips get smaller and more powerful, as latency starts to disappear. 5G networking, we don't really know what the impact of that will be right now, but it's fair to say that we've spent a lot of time centralizing IT processing and data and operations. You would have done that either on-prem or people are doing it in the cloud. It's fair to say that we now need to start to think about what happens when some of that gets distributed back out into the field on devices in high-performing networks. And as anyone that works in the cloud will know, one of the hardest things to do when you're looking at cost is to figure out what your network charges will be for data coming out of your environment. So we need to start thinking about that a lot more, because Internet of Things and, as I say, edge computed, distributed services are coming, and we need to think about how we set up cloud platforms and how we do our cloud engineering to incorporate that. Low code, no code. So a lot of the things we do for our clients right now is less about deploying applications in the cloud and more about setting up a platform service that developers can have access to and to do things. And what we know is that a lot of the cloud providers, a lot of their R&D is being focused on making the cloud accessible for developers and taking away a lot of the platform considerations. And low code, no code would be a part of that, to my mind. So we need to start thinking actually less about point projects of deploying applications and more about providing services at a platform level for developers to go and consume. And the low code, no code movement is a part of that. It's going to be really interesting to see where the cloud providers take this, but it will absolutely impact successful cloud adoption and cloud engineering moving forward. And then lastly, time to value. So I categorize this as how quickly can the value of what I do be realized and what are the accelerators to help me there. I think organizations have had enough now of starting with a blank sheet of paper every time they want to go into the cloud. We've been doing this for a long time now, near on a decade. And so what's really important is that we have a set of best practice encapsulated with code that can be adopted by organisations and projects as accelerators to get them there. And there will be projects that require their own bespoke solution. That's absolutely fine. But there may be many projects that actually require to do something quickly, aligned with best practice, don't have any other requirements over and above that, and an accelerator can get them there quicker. And it's that time to value. What is the value of what we're doing and how quickly can that be realised? Our organisations are really starting to talk to us about around the cloud. And then this is my last sort of thing around what the future may look like. We constantly talk about what's the difference between like a platform engineer and a developer, and the Venn diagram of what the difference is slowly sort of coming together, and that's what I've attempted to encapsulate in this slide. I think we are moving towards an era where, whatever you want to call it, full stack engineering, DevOps, you know, an engineer is an engineer, and they will have the tools available to them at a platform level, at a development level, at a test level, to be able to get on and do their job very quickly. And what distinguishes us as engineers will change, and the skills we need as engineers will change. But I very much foresee, you know, whilst we will all have specializations and a history of what we traditionally work on, I very much see the new era of engineer being someone who can do a bit of everything. And that bit of everything gets easier as the tools and technologies we need to do our job become more automated and become more entrenched in cloud and cloud delivery. And that's something that as an organization, you need to start to think about in terms of your project delivery, in terms of your structure, in terms of how you develop IT solutions in the future as well. Okay. Thank you very much for taking the time out to listen to me. I'll just go into the chat now and see if there's any questions. Okay, there's no questions. I've either stunned you all into silence or you have left and definitely don't believe anything I've said. If you would like to get in touch, my email address is up there. I would love to be challenged on anything I've said. I would love to be informed around anything you've seen in the field. Or if you've got a question about something I've said, I would love to take the time to answer it a bit more. I've got chat to come through. So, great question. Which platform is preferable in BJSS? We are cloud agnostic in that respect. So we don't have a preference. I think it's fair to say that in line with the market, we do have more projects on AWS, but that's not because we prefer AWS. That's just because AWS has the lion's share in the cloud computing market as a provider. What I will say is that we don't go to clients and say we think that this cloud provider is the best one. What's quite clear across Azure, GCP and AWS is that they all have their individual strengths, and understanding what those strengths are really part of successful cloud adoption, because it might be that as an organization, the thing you want to achieve is best aligned to one of them. And there's also other considerations around where Amazon are going as an organization that you might actually see them as a competitor as well. So there are non-technical considerations around risk that determine what cloud provider you might want to go to, but these are things that we're experienced in, and we spoke to large enterprises about, and they all factor into the decision making of what cloud provider they like to use. Okay, and the second part of that question, I think I've just attempted to answer, in which, how does a customer decide which platform to go for? Base it on what you need to achieve. They are of breed at, and also consider the non-functional cloud provider might actually ultimately end up being a competitor of yours. Okay, I am at the hour. I appreciate I've run out of time. Thank you all very much for taking time out of your day. I hope you've enjoyed it. Again, if you've got any questions, please get in touch, and I hope you enjoy the rest of the festival as well. Thank you.
Thank you very much, everyone. Just as a side note, there will be a recording of this on bjss.com/Sheffield, and that's where we'll host all of our other events. So if you'd like to look into some more BJSS events, please go to bjss.com/Sheffield. Thank you very much, Mike. That was a great talk.